So, let's get started. We're going to start with a mold that already exists. In this case, the oil cooler. This mold happens to be done in two halves, so they're basically a mirror image of each other, with the intention of pulling these apart to get the actual part out once it is done curing. But this is a CAM session, not a CAD session, so we're not going to talk about how to make this in the digital world. We're going to talk about how to make this in the real world once we already have this model. Oh dear. Are you going to talk back to me?
I'm gonna... Oh, shit.
Is that me or is that you? Try it again.
Can you hear me now?
Yeah.
He's not there.
Yeah, I am. I'm here. Hello? Can you hear me? Hello? 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 Are you there? Hello? Hello? Confirmation. Somebody tell me if they can hear me.
Can you hear me?
Yeah.
What about now?
Yeah?
Alright, cool.
So we good?
Yeah.
Okay. So this part, as I was saying, has another half that's just a mirror image of this. But we're just going to talk about how to write the code for this half, which is actually the same for the other half. So the first step in CAM, for those of you who don't know, we use HSMworks. It is a free download and install from Autodesk. It goes right into SolidWorks, and it adds this little tab here and this CAM tab here.
Yo, Zolan,
What?
can you put up that mold file onto the drive?
Sure. It is in the manufacturing folder of 2019. Oil cooler shroud example. Alright. Should I continue?
Yeah.
Okay. So, the first thing you have to do when you open up HSMworks in SolidWorks is define your stock and define your origin. So to do that, you have to create a job. By default, it will select all of the open or all of the non-hidden bodies that are in your part under the model selection, which in this case is what I want. Z is always going to be in line with the spindle, so Z is always going to be up and down basically. So you need to change it so the top of the face is in the Z direction. Usually you want X to be in the long direction, the longest orientation of the part. So you can change this tab. Usually I use the option Z-axis and X-axis. I already picked Z, and I can define this as my X, and that's what I want. For the stock, in this case, a relative size box with no additional stock except on the top face will be good. It's pretty straightforward, these options. Don't worry about those too much. You'll figure it out pretty easily. And then the origin, for the router, we want it to be the bottom left corner, or any corner. Typically we do the bottom left, but on the bottom face of the part, so down here. So to do that, you go model box point, and then you have all these options, and you can see we want bottom corner, and then just click through it until it gives you the one you want. There we go. Except I want X to be the other way. There we go. So that's what we want. We're done with that. We have a nicely described stock size. Typically our parts are going to be pretty much just glued down. Oh, that is interesting. It is not square. Wonder why. There we go. That's better. Okay. So, next thing we have to do is decide what tool we're going to use. So we have holes that are 1/2 inch. So if we can get away with a 1/2 inch tool, that would be nice, because then we can just make the hole with those tools. Based on the fillets, the vertical fillets, they're all bigger than a 1/4 inch. So there's no reason we can't use a 1/4 inch or a 1/2 inch tool to do those. The only limiting thing here are these bottom face fillets, which are, for whatever reason, 0.24 inches, which is fine. That just means we have to use not a ball nose tool, we have to use a bull nose tool. So I will show you what that looks like. So you see how this tool has a slight radius on the corner, but not fully radius? That's what you would call a bool, like B-U-L-L. Bool nose tool. Did someone ask how do you pronounce that?
No.
Okay. Yeah, anyway, this is what we're going to use. So we're going to copy these numbers into here. Go to the tool library, new mill tool. For the router, this number is not going to matter. For the actual CNC, this would correlate to whatever number the tool is in the turret. For now, 1 is fine. This matters. I'm just copying all this from the MSC page. Alright, so that's good. Feet and speeds, let's just set it to that for now. RPM does not matter for the router. You just set it sort of manually. Yeah, so that's all good. There's our tool. Now we can start roughing it out. So the roughing strategies that you're going to use on router parts vary a little bit, but typically it's going to be an adaptive clear, which is sort of a smart toolpath, if you will, or just a 2D or a 3D parallel, which is not quite as smart, but for parts that are more of a flowing surface than a part with a big cavity, the parallel will be faster, and not really any difference in quality. So once you select your toolpath, you have to go in and edit all of the parameters. This is feeds and speeds. This is your boundary, which in this case we have no boundary. We want it to do everything. Heights. The default heights option for in this case are going to be just fine. Now these two tabs, specifically this tab, you're always going to have to change something. An optimal load of 0.2 is a little bit much for most of our equipment, so we're going to do 0.1. Maximum depth, let's just do 1 inch. And I'm going to go back and explain what all these are in a second. Fine step down, 0.5. Change that, stock to leave, that's good. Okay, so the 3 critical things here, rather the 4 critical things, are this, which is basically the step over in the X and Y plane. So whenever that tool takes a cut, you have to tell it how much material it has to move, it has to take off in the next cut. And every cut, actually, every cut's going to take the same amount of material with this toolpath. So it's going to move over 0.1 inches with every pass in X and Y. This is sort of the same thing in Z. Every depth is going to be 1 inch. The fine step down is basically, once it does a 1 inch pass, it's going to move up that fine step down to just finish getting all the radiuses. You'll see what that looks like in a second. And then stock to leave is just how far away it stays from the final surfaces, because we don't want to gouge the part yet. This is a roughing toolpath. We don't want to touch any of the finished surfaces yet. So we'll let that generate. And there you go.
What?
So if I get rid of the linking moves, you can see the cutting operations, which are all the blue lines, and some takeaways from this. There's going to be the first cut at this height, first pass, the second pass at this height, and then you can see the fine step down in between going in to clean up all the radiuses. So this is right. You can see the step over. It's about 0.1 inches between each line. You can see that this does go into these little cuts. It does not, however, go into these holes, which is fine. Okay, so that's done. That's roughed. Next we can move on to finishing, which basically you have three real options. These three paths: contour, parallel, and scallop. Typically you're going to use a contour or a parallel, and those are the simplest. Basically, a contour is going to step in Z at whatever amount you define, and a parallel is going to step in X or Y in whatever amount you define. So for this part, I'm going to use a contour with the same tool. The boundary, there is going to be a boundary for this one, which is going to be this sort of big cavity. So I'll just go around, select that. Until it does what I want. There we go. So see how the red line on the bottom is just that cavity? That's what I'm looking for. Tool, outside boundary, that's fine. I don't think that option is going to matter. So back to this tab, this fourth tab. Maximum step down, we're going to make that 0.05. And then see what that looks like. Okay, so it's going to step down the walls. That looks fine. But the problem here is that once it reaches this bottom face, because it's such a shallow angle, it approaches being just a flat face. You end up with these huge step overs in the toolpath, which is not what we want. So unfortunately, with a contour operation, you can't fix that, really. There's nothing you can do to change that unless you make your step down really small, but then you're just adding an extraordinary amount of time to your toolpath for no reason. So we're going to copy these parameters into a parallel toolpath, meaning the selection will stay, the step over will not, because it's a different direction. And with a parallel type toolpath, you have a little bit more control. Specifically something like this. You can turn that on, and then you can add a little bit more definement. So you have, notice you have a horizontal step over as well as a Z step down, and with those two things we should have a toolpath that will clean this up acceptably. It's still generating. That is taking a long time. Okay. Come on. Alright, so it's still not done, but for now, let's be fine. So, we're still not there yet. Notice there's still a spot here, this back face, that it is not gonna clean up the way we want. I still think we'll be able to get away with this type of toolpath. We just have to change the direction that it cuts. And usually, a 45-degree angle is suitable. So let's see what that looks like. So I do not want it to go all the way down, so I'm just going to change that real quick by changing the planes. This bottom plane I can just select here and then do minus 0.1, or we'll do minus 0.2, and that will fix that. Okay, so this still does not work. This still is not going to clean up this face. Good enough. So, but it looks really good on this side, just not on this side. So my thought is, well, why don't I separate this toolpath into two halves, and then they'll both look like this, and then it will clean up quite nicely. So I'm going to go in. We can delete the contour, because we don't need that. Go in and change the selection. Now, the first time I did this, I just clicked around this edge. An easier way is often to just make a sketch. I'm just going to click on that so this does not throw an error. But go in, make a sketch. Just convert that. There you go. So now I have a sketch. I'm going to hide this temporarily. Edit toolpath. And now I should be able to do this. I don't think that line extending is going to cause any problems. Ah, there we go. So I can just deselect that, and it is smart enough to close that. So there's that. We're going to duplicate this. Select the same thing on this side and change the angle. So rather than being 45 degrees, we're going to make it minus 45 degrees. Now, if I show this, oops, we have one toolpath here with a little bit of overlap. I'm not sure why there's a different width. But it shouldn't really make a difference. And then a mirror image of that toolpath right here, pretty much. Two other things we have to do, and this is going to be not a typical router thing, except for parts that are split like this, which is the holes and these little slots. Those slots are basically there just to allow you to stick a screwdriver or something else in there to pry these two things apart. They're not a very important surface. The only important surface is this cavity. It's the only thing that actually matters in the end. These pins, or these pinholes rather, are just to put pins in so you can align these two parts whenever you put them together. So the easiest way to add these slots is going to be with a 2D contour, which basically just follows an edge with a tool. So same tool, select this edge, nope. Select here, uncheck these. There we go. So if you turn off propagate along Z but leave on tangent propagation and click the start and end of your contour, generally speaking it will select what you want. I'll do the same thing over here. Notice this arrow is the wrong direction. I have to fix that right now. There we go. I just had to even click one. Smart enough to know what to do. So that's it. None of these settings are going to matter for this one right now. I lied. So we don't really want it to plunge right here. We'd rather have it smoothly feed in. So I'm just going to basically extend this a little bit. 0.3. There we go. I just extended that line basically. Now it'll plunge outside of the stock. And one more thing, and we're just going to drill with an end mill. As long as it's center cutting, which it should be, it'll be fine. Click on the two holes and click on this and make them go just a little bit deeper. Should be good. We're going to change the plunge feed rate to 10 inches a minute, so it's nice and slow. Non-drill, yes. You know, we're using an end mill. It's warning us. But that's fine. And there you go. So that's it. The best way to check this before posting it is to select the job and go to stock simulation. This slider bar controls the speed of the simulation. Generally, it's really touchy, so you have to go pretty slow to like see what happens. We're going to slow it down, hit the play button, and then turn off the actual CAD file. So this is the roughing. It's going to start like that. We'll turn it up. Go. It faced the top of the part as part of that. This next thing. And I think it does one more depth. Yep. So I'm going to slow it down. There. I can go back. So you saw. Come on. Don't crash on me. Well, while this is doing this, you can sort of see an artifact of a minimum step down with these little lines on this part. It was a lot more evident on the bottom, which is what I was trying to get to. See, I always forget to save things too. I should have saved this at some point, and I didn't. Oh, great. This might be the end. The one thing that I did miss was facing this part. So I was going to go back and add that operation. But otherwise, this part is programmed and it would work just fine in the router. Does anyone have any questions while this is trying to repair itself?
HSMworks.
We'll send out a link, or send out an email, links where to get the add-on.
So, unless someone wants me to show them something specific, that is a wrap. That is everything you need to know to program a part. I'm gonna stop recording now.